Hi everyone, in this lecture we will see the operation of class C chopper. A class C chopper is a two-quadrant chopper that can operate in the first and second quadrant of output voltage and the current plane. So it is a combination of class A and class B chopper. In this type of chopper, the power can either flow from source to the load or load to the source. So it can be used as a step down or a step up chopper. In the first quadrant, the output voltage and current should be positive, whereas to get the second quadrant of operation, the output voltage should be positive and the output current should be negative. Now let us see the working of class C choppers separately for each quadrant of operation. In the first quadrant of operation, there are two cases we have. In case 1, the chopper 1 is on, and case 2, chopper 1 is off. So when the chopper 1 is activated, the output voltage is equal to the source voltage, which means the output voltage V0 is equal to VDC. So if you look at the load current I0 is flowing forward and storing the energy in the inductor. So when the chopper 1 is off, the load current stops flows in the circuit. If you look at the inductor creates a reverse polarity voltage to maintain the load current to prevent an abrupt decrease. So during the inductor discharge period, the load current again stays in the forward direction. So as the output voltage out V0 and the output current I0 both are positive. So we can say that the chopper works in the first quadrant of operation. In the second quadrant operation, we have two cases, the chopper 2 is on and chopper 2 is off. Let us turn on the chopper 2. The EMF in the load that makes the current flow backward through the inductor chopper 2 as shown in the red color arrow line. So when the chopper 2 is off, the saved energy in the inductor is used to force a current in the opposite direction through a diode D1 and back to the source. At the same time, the D1 is conducts and the output voltage V0 is equal to a source voltage VDC. Now we can see that the output current is going in the opposite direction in the case 3 as well as case 4, but the voltage at the output stays positive. That's why the chopper works in the second quadrant. Now look at the waveform of class C chopper. When the chopper 1 is on, the I0 increases gradually to the maximum value and the V0 will be positive. When the chopper 1 is off, the V0 is 0. If you look at this blue line, the V0 is 0 and the I0 is decreases gradually through a diode D2, which represents a discharge of current in the inductor in the forward direction. So when if you see the chopper 2 is on, the voltage is 0 and the I0 is increases negatively due to the flow in the reverse direction. So when the chopper 2 is off, the V0 will be positive and V0 is positive and the I0 decreases gradually from negative maximum through diode D1, which represents a discharge current of the inductor in the reverse direction. Since the output voltage is always positive, whenever the chopper 1 is on and chopper 2 is on, the output voltage is always positive and the output current is either positive or negative. That represents the reverse power flow. So the power flow from source to the load when the chopper operates in the first quadrant, and whereas the power flow from load to the source when the chopper operates in the second quadrant. So whenever we use this kind of a circuit, it should be taken care that both the switch, that is the chopper 1 and chopper 2, should not be turned on at the same time because it results in short circuiting of a DC supply source. Class A chopper is used for motoring and regenerative braking of a DC motor. In the first quadrant operation, the DC motor operates in motoring mode and which it receives the power from the source. So when the braking is applied to the motor, it behaves as a generator, whereas it supplies the power to the source. So this is used for a regenerative braking application.